Welcome to Algebra 1 Honors. We are going to look at Lesson 5-10, Factoring by Grouping. This is a fun lesson, okay? And your eyeballs are going to be your great assistants in this lesson, okay? We're going to look at 6 problems in total. 4 are on the board here, and I'm going to put 2 more in a minute. Let's look at this first one. What your eyeballs should be telling you when you look at this problem, okay? Left or right eyeball should be looking there, and the other one should be looking here. And your eyeballs should be saying to each other, "Oh my goodness, we see the same thing. X plus Y, X plus Y. Oh!" Okay? So when your eyeballs tell you that, the way you factor by grouping is to take the common element and pull it out, factor it out. So we're going to take the x plus y, okay, which is what our eyeballs tell us is common, and we're going to pull it out over here. We're going to write x plus y. Then we're going to make a second set of parentheses, and everything that's left over goes in there. 3 plus z. Okay? Now, the way we would check this is to FOIL these 2 binomials here. You remember how to FOIL? First, outer, inner, last, we'd multiply. And then we'd distribute the 3 and distribute the z up there, and we would get the same answer. Okay? Now, let's look at this next one. Oh, my eyeballs should be looking right here. And right here. And my eyeballs are telling me, "Oh my goodness, they're almost the same. Y minus 2, almost the same as 2 minus y. Oh, what can I do? Because if I could make them the same, then I could pull that out as my common element." Okay? So, left eyeball and right eyeball say, "Oh, they're almost the same here." And there's a minus in between. So what I'm going to do is factor out a -1. And I can pick either one of these and factor out the -1. I'm going to take this one because I like the variable to come first. Okay? So I'm going to take a -1 out here. And what that allows me to do is to switch the y and the 2. Because look what happens if we multiply this back. We get -1 times y is a minus y. -1 times -2 is a plus 2. And what we have is the same thing as 2 minus y, which is what we started with. Okay? So when we have 2 factors, and they're almost the same, okay, there's a minus in between them, and they're almost the same except the 2 elements are switched, we're going to pull out a -1. Pulling out the -1 allows us then to commute or flip the 2 elements here, the y and the 2, and the minus stays in between. Now that doesn't work for a plus. If that was a plus, if it was a plus, we can just switch them without, if this were y plus 2, right, that's the same thing as 2 plus y. Because addition is already commutative. Subtraction isn't. 4 minus 8 is not the same thing as 8 minus 4. Okay? It's the same thing as -1 times 8 minus 4. So when there's a minus, you have to pull out a -1. Okay? So then what we have x times y minus 2 plus w times -1 times y minus 2. When we pull the -1 out, now left eyeball and right eyeball say, "Okay, they're the same." So I'm going to take the y minus 2, pull it out, because it's what's common. And in parentheses, I'm going to put everything that's left. Well, there's my x. And then here, -1 times w gives me a minus w here. So it's going to be minus w. And I'm done. Okay? Now let's look at the next one. They've already grouped it for us. They've already put parentheses, grouping symbols around the two elements each that they want us to look at together. So let's take that as a hint. What can we factor out of here that's common to this term and this term? Well, we can take a 3 out of both the 9 and the 3. So let's pull the 3 out here. We're factoring out our monomial, our biggest monomial that we can find. And if we take the 3 out of 9, we're left with 3. And if we take the 3 out of 3, we're left with 1. Okay, because 3 times 1 is 3, 3 times 3 is 9. Now we can also take, it looks like, a p, the variable p, out of both. Well, 1p here, don't need to put another one, because 3p times 3 gives me my 9p back again, if I distribute that. But there was a q here, so I still have to put my q in there, because 3p times minus 1q gives me minus 3p cubed. Now, plus, let's see what we can factor out here. Well, it looks like we can take a 2 out, and we can also factor out an n. So if I factor a 2n out of here, what I'm left with is the q, and a 2n out of here, I'm left with a minus 3. Okay. Now, my eyeball should say, oh, almost the same here and here, but they're switched again, and they're a minus. So that means that over here, I'm going to pull a minus 1 out of here. So I have 3p times minus 1, and then my 1q and my 3 are going to switch. And I'm going to drop the 1 in front of the q. And I can put the 1 back here, or I can drop it. Now, over here, then I have 2n times q minus 3. Now I've got an element that is exactly the same. My q minus 3 here, and my q minus 3 there. So I'm going to pull out the q minus 3, and then what's left goes in another set of parentheses. Well, what's left is minus 3p plus 2n. Okay? And you might write this as 2n minus 3p. Same difference. Okay? Now let's look at this one. Number 4 is a little bit different. In number 4, okay, if you think of it this way, we have triangle squared, and in our triangle is a plus 2b minus, and let's make this one a rectangle squared, and in our rectangle is 2b plus c. Well, if you look at that, triangle squared minus rectangle squared, that's the difference of two perfect squares. And the difference of two perfect squares, we've already learned how to factor, right? We make two sets of parentheses, one with a plus in the middle, one with a minus in the middle, okay? And then we take the square root of triangle squared. Well, what the triangle is a plus 2b, okay? And the square root of this one, which is 2b plus c, and then we take, again, the square root of this one, okay, and the square root of this one, okay? And that's how we factor. Now, then we have to do some combining of terms here. We've got an a, no more a's in here, 2b here, another 2b here, that's 4b, and our c term there. So that's when we simplify in parentheses. Over here, we've got 1a plus 2b minus 2b, so the b's are going to give us a 0, and then that minus makes us a minus c. Okay, and there's my answer. Now, let's look at two more problems here. And I'm going to stop the video and do a continuation so I can wipe down this board.